So, Shabab, as you can see, that the lecture today we're going to talk about risk identification. Don't forget that in our last discussion, as I explained to you, I told you that risk assessment basically consists of risk uh, identification, risk analysis, and risk evaluation. All right. So basically, firstly, let's try to differentiate between what we call risk or hazard analysis and risk evaluation. Don't forget that in the last lecture, we also discussed about the difference between the hazard and the risk. What basically a hazard is a source of harm. Risk is the likelihood that harm will be caused. All right. So hazard analysis basically means identifying the sources of harm and determining their severity, their consequences, while risk assessment means what are the likelihood of those hazards, as well as what is the effectiveness of what the controls, existing controls or recommended controls. Now, the fact that hazard exists does not necessarily mean that risk is produced, okay? Because basically it depends on the exposure of people to that hazard. So once you have hazard, the risk will depend on the likelihood of it occurring. So risk is actually a function of likelihood, which is the key word. Okay. Risk is a function of likelihood. So we say risks are derived or produced from hazards when people are exposed to it or assets are exposed. And this poses a chance for loss. Okay. Okay. And there's a chance that there's going to be loss, there's going to be an accident, there's going to be fatalities or injuries, or there's going to be damage to the equipment or damage to the environment. When there's a chance for this or there's a likelihood for this, it could be low or it could be high, and this is when you actually say there's a risk. So for a risk to occur or to exist, the exposure to hazard must pose the severity of loss or harm, and the likelihood of occurring. So if there's nobody, no person, or no assets is exposed to the hazard, then there is no risk. All right. Now, this chance for loss or risk is measured by the likelihood, as I've said again, which is the expression for the risk, is measured by the likelihood of the event occurring and the resulting severity or consequence of the loss. Now, you can see in these two flow charts or flow diagrams, you have the hazard analysis as well as the risk assessment. You see that hazard analysis stops here while risk assessment continues. All right. So basically, hazard analysis involves identifying the hazards and the exposures, right? Possible exposures to those hazards and severities. What are the severities of the hazard? So basically, hazard analysis is basically identifying the hazard and determining the severity of those hazards or the consequences. Okay, the hazards and the consequences of the hazard. Now, this is what hazard analysis involves. When we move on to talk about the likelihood, then you have the risk. All right. So you can see risk assessment here. You not only identify the hazards and determine the severity or consequences, you also determine the likelihood of it. So, and the risk score can be calculated by this formula, which is the severity multiplied by the likelihood to give you the risk. And there could be other formulas as well. Now, this one also shows the two phases of hazard analysis and risk assessment. Okay, you can see that the first phase we have hazard analysis, and the second phase we have risk assessment. In the first phase, firstly, you establish the purpose and the scope of the hazard analysis and risk assessment. I know we discussed last time what does purpose mean. Purpose simply means that you establish the reason, the scope, the area, where you're carrying out risk assessment, and things like that, the context and the scope of work. Next, you identify the hazards. Okay, it could be a hazard related to a particular kind of material or a facility or specific tasks. Okay, and things like that. You also identify failure modes if equipment, processes, systems, assets are involved. Okay, identify failure mode for that. You have equipment. Okay, you have processes. you have assets. You see, what are the various failure modes? Failure modes means modes of failure. How could something go wrong? What could go wrong? All right, so you try to identify that. Next, you identify current controls. All right, what are existing controls? Okay, frequency and duration of exposure. Okay, next, identify frequency and duration of exposure. Still, we are in hazard analysis. And then next is what severity of consequences. Okay. So basically, all of this makes up what you refer to as your hazard analysis. You come to the next stage, which is the risk assessment, where you analyze the likelihood of the risk. Okay. And this you define the risk by calculation, where risk is going to be the severity multiplied by the likelihood. This is the severity, and this is the likelihood. Okay. In some other cases, you might have some other factors like vulnerability or rate of damage and things like that. You may have that incorporated into the definition of the risk, and then the formula might be slightly modified. But the general formula is simply to multiply the severity of consequence by the likelihood. Based on that, you can prioritize the risk. Okay, you can prioritize the risk from the highest levels of the risk to the lowest levels of risk. And then you can determine if the residual risk, that's the risk that remains after the controls have been implemented. Okay, once you've analyzed the controls, okay, once you factor in controls, then you can determine what the residual risk. So you determine if the residual risk is acceptable. If yes, then you can document your findings. If no, you can implement additional controls and go back to identify hazard. It's a continuous process. And while you implement additional controls, you may want to reassess the severity, okay? The frequency and duration of exposure might change. The likelihood might also change with new controls. So new controls may change the likelihood, may reduce the likelihood of occurrence. New controls may reduce the severity of the consequences, and new controls may also reduce the frequency of exposure. All this.
Sorry, doctor.
Yeah, what did you say?
The slides doesn't change, doctor.
You can
yes,
see.
doctor. I was raising my hand, but you did not respond.
Okay.
It stopped at slide number 1.
Number 1.
Yeah, now it's changing.
So can you see it now?
Yes.
Where did it stop? It stopped here?
It was in at slide number 1, and now you are displaying slide number 3.
Are you serious? So did you see the slide when I explained it? This one?
Oh, well, the slide that did not change never.
All right. So basically, we're talking about risk assessment, risk identification, as you can see from my slide. And I was trying to tell you guys that the fact that a hazard exists does not necessarily mean that a risk is produced. Okay? And risks are derived or produced from hazards when their exposures to people or assets pose a chance for loss. Okay? And for a risk to exist, okay, the exposure to a hazard must pose a severity of loss or harm. As you can see here, when I said that if there is no person or no asset is exposed to the hazard, then there is no risk. Okay, and I said that the key word for risk here is the likelihood, as you can see as well. And next, I went on to talk about the chance for loss or risk is measured by likelihood. Okay, as you can see. So next is that I showed you that this is the flow chart or flow diagram for risk assessment. You can hazard analysis. You can see that hazard analysis start with hazard identification as well as what identifying the consequences of the risk. So you have hazards here, okay, and then you have the consequences as well. Okay, and as for risk assessment, simply you identify hazard and exposures, you choose the severity, okay, consequence of concern, and then this goes further to identify what the likelihood of occurrence. Okay, this goes further to identify the likelihood of occurrence. So you can analyze how events could occur and its likelihood, and then you could estimate the risk. As I told you guys, estimating the risk here is severity multiplied by the likelihood. And there could be other formulas as well if you want to include, for example, the rate of failure or the damage or vulnerability and things like that. In this other diagram, I showed you here the two phases of risk assessment and hazard analysis. The first phase is the hazard analysis phase, and the other phase is the risk assessment phase. Okay. So, in the first phase in hazard analysis, first we have what you call the establishing the purpose and scope of work for the hazard to be carried out. Next is to identify the hazard, which may be related to equipment, processes, materials, tasks, and things like that. And then you identify failure modes. That's modes of failure. It goes also modes of failure of equipment, processes, assets, etc. And then you determine if there are existing controls. What current controls are in place? Okay, what current controls are in place? And next, you analyze frequency and duration of exposure. That's exposure of people to these hazards, and analyze the consequences. Okay, the severity of consequences, frequency of exposure. Next is to talk about the likelihood. Okay, where the likelihood characterizes the risks. Well, you have S, severity of consequence, and L for the likelihood of the risk. The next thing is for you to define the risk as a what function of what severity and likelihood, where you have S multiplied by L as the risk. In the next phase, you do what you prioritize the risk from the highest level of risk to the lowest levels of level of the risk. Okay, so you have the residual risk. You tell me if the residual risk is acceptable. If this is yes, then what you do is that you document your findings. And if this is no, you can select additional controls. These additional controls may help you to modify the frequency of and duration of exposure. It might also help you to modify the severity. Okay, analyze the severity of consequences. It could also help you analyze the likelihood to modify the likelihood of occurrence. These three. So you may go back and modify these three. Now, hazard identification, you can say hazard or you can call it risky, as we already discussed previously. It involves firstly finding, anticipating, recognizing, and describing the hazards that could affect the achievement of the organization's objectives. Organization's objectives here is more a general term. Here will basically mean safety of the organization, of the workplace, or the work processes. Okay, these are basically objectives. So now we could talk about finding. How do you find? How do you search for the hazards? How do you anticipate them? Okay, how do you recognize them and how you describe them? All these forms what you call hazard and risk identification. So hazard identification can be used as a standalone technique. It means alone without going further to carry out any risk assessment. Or it could be the initial step in more detailed risk assessment methodologies. All right. So firstly, what we do in hazard identification is one, you identify the hazards. Okay. How do you identify the hazards? We're going to discuss each of these stages. We're going to discuss it in the next steps. So first, you identify hazards. The next thing is what you identify exposures and failure modes. Exposures means how could people get exposed to this, and for how long could they get exposed to this? How long, for example, in terms of noise? Okay, you want to know if people are going to get exposed for about 8 hours or less or more, things like that. And what kind of failure modes how could the system fail? The equipment, the system, the process, and things like that. Then next, you are trying to identify the causes and triggers. Okay, what could lead to this? What are the causes? What are the triggers? What could trigger this hazard? Next is to try to identify the controls. Okay, identify controls. How can you control this? And 6, you identify the consequences. You describe the severity of the consequences. Or 5, sorry. You define the severity of consequences. Okay, so this steps takes you through the hazard and risk identification process. Now let's start with the first one, which is what to identify hazards. Now, identification of hazards is one of the most important steps in risk assessment because hazard is the source of the risk. If you cannot recognize this hazard, then you cannot assess the risk and you cannot reduce the damage. So basically, insufficient identification of the hazards will lead to improper assessment of the risk, and this ultimately will jeopardize your risk assessment process. Okay, here risk cannot be identified, assessed, and reduced or managed if you cannot properly identify hazards. So hazard identification is one of the key steps towards risk assessment. So basically, the identification of existing and potential hazards within the context of the assessment be performed. In addition to listing the hazards, we don't want to just list the hazards. We want to provide also a description or characterizations of the hazard should be provided. And this is a situation where you describe the severity of the hazard, the consequences, the routes of exposure, how could they be controlled, and things like that. So there are many references and resources for you to do this, standards, guidelines, checklists, and things like that. OSHA has a job hazard analysis tool. You can find it in this link. You could also use some guides presented by some people. This is OSHA Academy. They present the training website. They present guides on this guide, this infographic that says you can use what? NIPS, materials, environment, equipment, people, and systems. So you can look at the materials being used and try to identify what hazards are related to the materials. You do the same for the environment. What are the hazards related to the environment? The design of the environment, the condition and circumstances around the environment, the equipment that is being used, the people, their level of knowledge, capability, and skill, the system of the design of the system, the procedure, and the process itself. Right? All this there could be hazard related to all this. You could also look at accident categories, various potential accidents that could occur and the causes of those accidents. Okay, so this here would be unwanted risky scenarios. Okay, this could be risky scenarios. So the accidents could represent risky scenarios, and then the causes of these accidents could be hazards. Okay. Could remain the hazards. So if I'd say we have crane and lifting equipment accidents or accidents related to the crane and lifting equipment. What could cause accidents in crane and lifting equipment? These causes could be identified as potential hazards because they are triggers. They are things that could trigger accidents here or trigger these risky scenarios related to crane and lifting equipment. Similarly, slip, trips, and falls. Okay, what could lead to slip, trips, and falls? What could trigger these? Trailing cables and all that. Electrical heat, chemical burns, all forms of burn. What would lead to this? Okay, so you could identify causes of accidents in all these various risky scenarios in your site, on your workplace, or related to this particular task, and you can come up with a list of hazards. You could also use this is used by the NEBOSH exam. Okay, this is used by the NEBOSH exam. So you could also use this where you firstly you determine noise, vibration. These are categories. Under each of these categories, you could identify various sources of hazard, causes, triggers, of these hazards? What are the sources of noise, vibration, radiation, mental ill health, violence at work, substance abuse, work-related or limb disorders? What could lead to this? From like the workplace design, ergonomic factors and issues, manual handling, load handling equipment, hazardous substances, what various kind of hazardous substances you have, and how could this trigger hazard through spilling, things like that. Health, welfare, work environment, working at height, confined space, all this work equipment and machinery, fire, electricity, all this. Similar to what I showed you in the previous slide, where we have here fire outbreak and explosions, electrical bonds, that's electrocution, scaffolding, accidents, So similar to that, you could also identify what are the triggers of all these various scenarios. What height, confined spaces, what kind of accidents could happen there, what could be the causes, and all that. All this could help you identify various hazards in your workplace. Okay, you could also use checklists that you may find available by other researchers and in the industry. So the next thing you want to do is that you want to identify exposures and failure mode. How could people get exposed to these various hazards? So the existence of a hazard alone does not necessarily translate to a risk. As we said, risk has to be derived from the exposure to the hazard. If people are going to be exposed to that, if people are going to be around where the hazards are, or if there's a way to people get exposed to it, or assets get exposed to that. So in addition to identifying the hazards, the potential exposure to people, property, assets, and the environment, and other things of value must be identified. Okay? So exposure is very key as well. So exposure to hazards could occur in various ways. This could include direct contact with the hazard, okay, like touching, spilling on you or your body, or things like that, or coming into contact with the equipment or the property. Indirect contact with the hazard through other means like radiation, conduction, things like that. Proximity to the hazard as well, being close to the hazard. Duration of exposure, like in case of noise. The magnitude of exposure in case of quantity. Concentration or dose of exposure. And you can see the different routes that these exposures could come into the body through inhalation, ingestion, inhalation from the nose, ingestion from the mouth, absorption from the fluid parts of the body like the nose, the mouth, and the eyes, injection by piercing through the skin or the surface of the body. So here, what are failure modes? Failure modes are modes of failure. These are different ways in which a system can fail to perform as expected or deviate from its design tolerance. And this could result in potential for harm or hazardous events. Basically, a system could fail to perform, okay, or deviate from its design tolerances, okay, which means it doesn't perform, it moves away from how you expect it to behave, how you expect it to perform. All this could lead to potential risky scenarios. Here, examples have been mentioned of system failures or failure modes, and this failure mode depends on the kind of equipment, kind of system, and depends on the kind of process that you are interested in. So if we see here, we have, for example, premature operation. That's when you have an unexpected startup or release of energy. Failure to start, when it doesn't start, you expect it to start. Failure to stop operation, like the failure of brakes. Failure during operation, like local exhaust system failure during welding. Degraded or deterioration of operation, like leak in a containment vessel or loss of containment. Exceeded capability, overflow, or over pressurization of the vessel. Okay. Reasonable foreseeable uses or misuses of operation, like using the forklift wrongly. Okay. So all these are examples of failure modes. Now we'll talk about triggers. How do you identify triggers and causes? Okay, first is important to understand the circumstances, conditions, actions, or inactions that can cause exposure to a hazard or trigger a hazardous event. All right. So these causes, circumstances, conditions, the actions or inactions are called the triggers. This is what could trigger it. This is what could lead to it. These are referred to as causes of the accident. Okay. So hazards can be acute in nature because it leads to immediate harm. Okay, immediate harm happens, or it could be cumulative, and we call this one chronic. It could be cumulative, occurring after a long period of time from repeated exposure, like hearing-induced loss, okay, or noise-induced hearing loss, okay, when you have loss of hearing due to noise, or you could have other things like when you have things that could cause cancer, things that are carcinogenic. Usually these are chronic effects. Now, basic causes may include machinery, design, selection, condition, use, and maintenance of the machine. All this could lead to or trigger accidents or hazards. It could be due to humans, which could come from actions, their inactions, their knowledge, their skill, interaction, communication, that is distraction and all that. It could come from the management, which could be, for example, the direction, supervision, enforcement. Okay, so you have poor direction and supervision from the management. You have lack of enforcement. It could come from methods. Okay, poor design, poor system, poorly designed processes, gases, and all that. To come from the materials, like what kind of elements it contains. If you have hazardous materials, for instance, or poorly selected materials, or handling, storage, use, and disposal of these materials. It could also come from the environment, like design and layout of the environment, the condition, other external factors like environmental factors like the weather could also influence or could trigger various risks and various hazards in the workplace. So here you can see various methods or tools that could be used for risk identification, all right? And you can see we have brainstorming, cause and effect analysis, checklist, Delphi technique, design safety review, failure mode and effect analysis, hazard, HAZOP, human reliability analysis, PHA, analysis, toxicity assessment. So you have various methods. Okay, we cannot cover all these methods in this course, but we're going to talk about some of them. Okay, some of the common ones, we're going to discuss them. Okay, so you have potentially a lot of methods. Some methods are suitable for some scenarios, and some methods are not suitable for some scenarios. So all this you have to determine in establishing the context of your risk assessment. Okay, you have to determine what kind of methods do you want to use for those risk assessment. And this will come, choosing any of this method will depend on the complexity of the problem, the risk assessment problem, the amount of time that you have, the data that is available to you, the skills of those that will carry out the risk assessment, and the kind of outputs that the risk assessment results will give you will determine what kind of risk assessment you want to select. Okay, so this is an example here of a job hazard and safety analysis. You can see, first of all, we identify the various hazards, determine the causes of the hazards, and then the consequences of the hazards. We call this JHA, job hazard analysis, or JSA, job safety analysis. All right. So first of all, you select the node, which node means what? The part or the system, the place where you want to carry out your job safety analysis. You can use some guide words to help you, like too much flow, less flow, you know, and things like that. Too much heat, less heat, things like that. So you can use from that to determine if the hazard is, if there's a possible hazard. And from that, you can brainstorm on the causes. You can also carry out research. Okay, you can refer to existing documentation or literature to identify what are the possible causes of those hazards. You can also consult professionals, operators, okay, operators, people working, they can also inform you about this. Next, you determine the controls. You record your hazard, okay. So this is the end of the hazard hazard exercise. As for a risk assessment exercise, you have to do more than this. You have to go further. All right. So basically, a job hazard analysis is likely the most common hazard-based analysis technique. It also helps you as a hazard identification process, as a hazard process. Okay. It is used by risk managers it could be called job hazard analysis. You can also call it job safety analysis. So it's a simple hazard analysis tool used to help stakeholders to identify, analyze, and manage existing potential hazards in the tasks that they perform. So these methods are used to review job tasks, identify the hazards that may have been overlooked in the design or redesign phase of the machinery, equipment, tools, workstations, or processes. All right, so you can see this another example here. We have tank sanitizing. You want to sanitize a tank. All right, you have the date, you have the person that carried out the job hazard analysis. Yeah, this sequence of basic job steps. This, by the way, can be gotten from the people that are going to perform the task. You can sit with them to break down the job task into various steps. So you have step 1, you have step 2, or you have step 3, like that. Now, okay, so now you also have these potential hazards and recommended procedures to use. So first, the first step now is the setup. Tank manway should be opened, the gamma jet placed into the tank. Okay, in doing this, you have to do what? Lifting the gamma jet is 25 pounds. An oaks from mixed tank. This could lead to a hazard, okay, because of the weight. Now, placing gamma in tank manway, poor position slash twisting, tripping over holes or twisting ankle, stepping on the holes, and you may be able to identify others. You may be able to identify all that by brainstorming, looking at past accident records, or discussing with the operators. The operators, when you brainstorm along together with them, may be able to identify even more potential hazards. You can see for this as well, washing the tank with caustic mix. Okay, this could lead to chemical dust, splashing of chemical mix, spray from the gamma jet. Okay, and this is probably a potential hazardous material. Burn from the hot water, because you're going to use hot water to rinse the tank. So you can have burn coming from the hot water, which could come from spray from the gamma jet. So you can see these are various ways to control that. So the recommended procedures to follow, okay, to ensure that you are able to avoid these hazards. Okay, so this is basically what you do in a JHA, job safety and safety analysis. You identify the sequence of steps that will be followed. You determine the potential hazards that will be that might occur in those processes, and you determine also what are the safe procedures. Okay? What are the recommended safe procedures? Okay, recommended safe procedures to avoid those hazards. So in these safe procedures, the controls will have been included. You include in it controls, okay, to ensure that you're able to avoid those hazards. Now, this is an empty checklist, okay, which you're going to use later on for an assignment. You're going to have the job task stated in these boxes, okay. What is the task or the sequence of steps that should be followed in the job task? You're going to have various hazard characteristics of the job task, okay, the severity of the consequences of those hazards. Who do you think might be at risk? Which persons do you think are going to be at risk? And then what are the existing controls put in place? What controls are in place, okay? So this is an example that you can do. You can also modify this. You can also include recommendations, okay? You may modify this and then include what? Recommendations. Okay, so these are some of the kind of things that you can do in job hazard analysis. So yeah, we're just going to look at some few photographs. They might be exaggerated, but it's just for the purpose of learning, for you to really have an appreciation of the risk, okay, or the hazards. You can see here this person on safe act. This is an improper use of the equipment. It could have potential injury or casualty even. You can see here this guy is also unstable, probably using the wrong access equipment from the way he's standing. At height, it looks unstable, and this material could fall over and it could fall along with it. So there's could be other ways, okay? One of the ways you can determine the best way to do this is to identify best practices in the industry, okay? What are the best practices or recommended practices in the industry for stacking, okay, and assessing those stacked goods, okay, and for carrying out various tasks in the workplace? There might be also guidelines. Those kind of information might be available in guidelines. And also sometimes you may also come up with innovative designs of the workplace. You see, this is also a wrong use of equipment, where someone is using this equipment to lift another equipment. Okay, so if you have a workplace where you know that you need to lift such heavy equipment to a place of height, then you should design the workplace to take consideration of this. Okay, design the workplace for consideration of lifting of these types of equipment. Okay, so this is also an unsafe act and wrong use of the forklift. This guy as well, you could see sitting on the guardrail of the scaffold, which is this not what the guardrail is not meant for sitting. Okay, it's only meant to protect people from falling over from the scaffold, and it's also not meant for people to stand and to gist and discuss. Okay, they can do this on the ground. All right, and you can see these guys are also not using any safety harnesses to connect them to an anchor point on the scaffold to prevent them from falling. You could see this as well. This is a potential source of fire or heat. Okay, and this is an explosive material. Okay, and this could potentially lead to an explosion. Right? You can see this guy as well here, where he's lifting this heavy machinery and heavy equipment and is walking under it. Okay, which could fall and collapse under him. So these are unsafe work procedures, unsafe appreciation of the risks and hazards present in the workplace. This as well, you can see is not stable, it's not properly, it's not using proper access equipment, okay, to work on at height, as well as this as well. So basically, this is just to show you an appreciation of the risks on various workplaces. You can see these are various tasks that are being carried out, and each of these tasks will have various hazards inherent in them. The variety of those hazards, persons that may be at risk, and then you have to put in place controls. Okay, controls are the existing controls may be in place, but you also have to maybe make recommendations if existing controls are inadequate. If you have inadequate or insufficient controls, you can also make recommendations. All right, so that brings us to the end of the lecture on risk identification. Okay, so thank you guys for listening.